Logarithmic functions. Let's try out some examples. A, we have log base 2 of 2 and it equals 1. Well, in this case we're trying to check and see if it's true or not, if it works. So log base 2 of 2 equals 1. Let's realize the logs. If you're taking the base 2 of 2, it's sort of like saying you're multiplying and dividing at the same time by the same number. What happens when you multiply and divide by the same number? For instance, 8 divided by 8 as an example. Well, technically it cancels out, right? 8 divided by 8, it doesn't give us 0, so be aware of that. It cancels out, meaning it gives us a 1. When you add or subtract, if it cancels out, then it gives you 0. But in this case, canceling out gives us a 1. So 2 divided by 2 would cancel out technically, but be aware, this is not quite the same as exactly multiplication and division. It's more of an exponents and logs. So once again, the log base 2 of 2 cancel each other out, giving us just a 1. So 1 equals 1. And that would be a true statement. B. In this case, we have log base 2 of 2 to the 4th. And once again, notice you're taking a log base 2 of that same number with the base, right? So the 2 is the base 2 to the 4th. So let's think about the fact that the 4 comes down to the front, and we'll learn in the future about what property this is, but for now we're assuming that this comes to the front. And log base 2 of 2, they cancel each other out, giving us 1. And the 1 times 4 gives us 4. So short version, we just say they cancel out and then the 4 remains. Just for this case scenario. So this is a true statement as well. Okay. C. In this case, we have log base 2 of 64. And now we're trying to write it differently, trying to make it make more sense. Since our base is 2, we're trying to say 2 to what base would give us 64. Well, the question is, how many times do we multiply 2, because it's a base, right, until we get 64? Let's see, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32, 32 times 2, we're basically doubling it, so that should give us double of 32. Hey, 64, agreed. So notice we were writing it into the previous formula that we had, right? Log base 2 of 2 to the 6. And once again, keep in mind the 6 comes to the front, right, when we're using the log function. And it becomes like multiplying and dividing. The 2's cancel out. So there we have a 6 times 1, or just 6. So in this case, there's our answer, 6. D. We have a log base 6 of 6 to the 4th. And do notice, once again, we have the same base 6 of 6. If we bring down the 4, the 6 cancel out, agreed? So we can convert this into a 4 times. This is actually showing you the steps that would occur, rather than just saying it cancels. But it still would work if you just say it cancels. So 4 times the log base 6 of 6. Notice the 4 came down as a multiplication, right? So the 6 cancel out. Log base 6 of 6 are canceling each other out, giving us just 1. So therefore 4 times 1 is just 4. And that'll be it. There's our answer. So, this is fine and dandy, right? Let's talk about a quick definition of a logarithm. Definition of a logarithm. For b greater than 0, b not equal to 1, and a greater than 0. The logarithm, log base v of a, is the number k such that b to the k equals a. So you can have a log, and it can be converted into an exponential format. That's basically all it's stating. Log base v of a is the exponent on the base b that gives a. We call b the base of the logarithm. So once again, notice the b value is what we call the base. Keep in mind that the logarithm is an exponent. So in a sense, it is technically an exponent, but we think about it as the opposite of an exponent in some cases to make our life a little bit easier. So once again, going back to our previous equations. There we go. Do you now see that they're kind of sort of equal and opposites to each other? Some practice will definitely help in this.